In this question, we are asked to find out the number of symmetric matrices of order n by n with each element being either 0 or 1. So we are asked to find out the number of symmetric matrices of order n by n. We are supposed to use only 0 or 1. Okay. How many such symmetric matrices can be formed? That is the question. Now first let's see a way to quickly eliminate a few options and find out the answer. Now let's consider the case for n equal to 1. So we are considering the case of 1 by 1 matrices. That means it have one row and one column. So how many symmetric matrices can be formed with 0 and 1? We can have one symmetric matrix with 0 and another one with 1. So these are the two options when n equal to 1. Now that means when n equal to 1, we have two symmetric matrices. So in this option, when n equal to 1, option A is correct, option B is also correct, option C, when n equal to 1, we have 1 plus 1, that is 2 by 2, that is 2 power 1. Option C is also correct. And option D, we have 1 minus 1 by 2 to power 0, that is 1. So option D we have successfully eliminated. Now let's consider the case when n equal to 2. So we are considering all 2 by 2 symmetric matrices that can be formed by 0 and 1. So we have all zeros. Then we can have 3 0 and a 1. Now let's write out all the possible options. Using 3 0, we can have one more symmetric matrix like this, and then using 2 zeros, we can have 0 1 1 0. Then using 2 0, we have one more option. This is also symmetric. Now using 1 0, we have this one, and one more symmetric matrix can be formed using 1 0, and all ones we can have the symmetric matrix. That means for n equal to 2, we have 8 symmetric matrices. Now let's once again check the options and see. Option A is 2 power n. For n equal to 2, we have option A as 2 power 2, that is 4. So option A is wrong. We need to get 8 as answer. Now let's consider option B, that is 2 power n squared. That will be 2 power 2 squared, that is 2 power 4, which is 16. So option B is also wrong. That means the correct option is option C. Let's check that quickly. Option C, that is 2 power n square plus n by 2. Substituting n equal to 2, we have 2 power 4 plus 2 by 2, that is 2 power 6 by 2, that is 2 cube, that is 8. So we have got 8 symmetric matrices. So option C is correct. Now let's see how we can do it in a systematic manner without using substitutions and our little tricks that we have used. Let's see how we can do that. We have to use a little help from probability theory to solve this problem. Let's see how we can do this. Now consider, we will first see a 3 by 3 symmetric matrix. We are looking for a 3 by 3 symmetric matrix. How can we form a 3 by 3 symmetric matrix? That is the question. For a symmetric matrix, we need to have A equal to A transpose. That means when we transpose the matrix, we should get the same matrix. Now we can form like this. We can have A, B and C here. Once we have put these three elements, we have to have the same elements here also, so that when we take the transpose, we'll get the same matrix. And here we can have another element E, and sorry, we'll put D here, and if we put E here, we have to have E here also. So we have A, B, C, and here we can have F. That means we have choice over 1, 2, 3, 4, 5, 6 elements. So 6 elements we can choose. The other 3 are not under our control. We are supposed to put it in the same way. So we have in effect 6 choices of elements. Okay, set it apart. For 3 we have 6 elements that can be chosen. So what are the elements that we chose? The chosen elements are the elements in and above the diagonal. So we need to find out how many elements are there in and above the diagonal for an n by n matrix to see how many choices we have. Okay. We have got 6 here because there are 6 elements in the upper triangle. Let's call it as upper triangle. So we need the number of elements in the upper triangle of a general n by n matrix. How can we do that? Consider an n by n matrix. How many elements will be there in total? That means we have n square elements. So let's say total elements be n square. Now how many elements are in the diagonal? That will be n, because for a 3 by 3 matrix we got 3 elements in the diagonal. We have got the number of elements in the diagonal. Now we need to find out how many elements are here. So how we are going to do this is, we are going to subtract from the total number of elements the number of diagonal elements. So we are going to find out total number of elements minus diagonal elements. Okay. Now what we have got? We have got the sum of this 3 and this 3, or we have got, by doing this we have got all the elements other than those at the diagonals. Now how many are there in the upper side? That will be half of it. So this is the number of elements above the diagonal or below, because both will be same for a square matrix. So we have found out the number of elements above. We can write it in terms of the equation. It will be n square minus n by 2. This is the number of elements above the diagonal. Okay, so we have found out the number of elements above the diagonal. So what we need is the number of elements in the upper triangle. That will be the diagonal elements plus elements above the diagonal. Okay, so we need the sum of n and n square minus n by 2. Let's see. So number of elements in the upper triangle, that will be n square minus n by 2 plus n, that will be n square plus n by 2. So this number of choices we have to make to form a symmetric matrix. We can choose from either 0 or 1. That means for each of these entry we have two choices. That means we have multiply to this many number of times. That means we have to multiply for an n by n matrix. Okay, we have for each of these, so this many number of times we have to multiply 2. It is another way of telling that the answer is 2 power n square plus n by 2, because we have to choose from either 0 or 1. Let's say we are given that we can choose from either 0, 1 or 2. Then the result will be 3 power n square plus n by 2.